All right, ladies and gentlemen, we're going to look at solving systems of equations and picking which way to do it. Okay, so the three ways of solving systems are, we've got graphing. And we know to use graphing if it's in y equals mx plus b form, slope-intercept, small numbers, and crosses at a whole number. Stop. When would we use substitution? When would we use substitution? When a letter is all by itself? When a letter is by itself on one side of the equal sign. Okay. And which is the final one, ladies and gentlemen? We've got graphing, substitution, and elimination. And when would we probably want to use elimination? When it's in what kind of form? Standard form. And that's ax plus by equals c. Okay. So those are the different ways we can solve it. What are the three? This is going to disappear, guys. Sorry. But it's up on the whiteboard. What are the three different ways to find the solutions? What are the three different kinds of solutions you can have? What do we call it if it crosses? Called consistent what? Independent. And if we were solving this, we would get what? An x and a y? Okay, like 2, 3. Okay, crosses at that point. What do we call it when it looks like this, when it's parallel? Inconsistent. And what would our solution look like? We would get like 2 equals 4, which doesn't make any sense, right? And we would call that no solution. Okay, what about ones that look like this, overlapping? What do we call that? Consistent dependent. And that would look something like 2 equals 2. And we would call that all real solutions. All right, now we're going to look at 3 different systems and try to figure out which way we want to solve it. Now we remember our 3 ways are substitution, graphing, or elimination. And we could get 3 different types of answers. Okay, we've got y equals negative 1/2 x plus 2 and y equals 2x plus 2. Which one do you think we're going to want to use? Is it in slope-intercept form? So we might want to use, what other one could you use? Could you use substitution? Could you use elimination? You could use any of them. But the easiest one to use would probably be graphing. So we're going to set up our x and y axis. Y is up and down, x is side to side. We're going to set up our scale. It looks pretty small, so I'm going to go by ones. Okay, the first one I'm going to start at 2. And then I'm going to go down 1 over 1, 2. Or up 1 over negative 2. And I'm going to get a nice straight graph. The next one, I'm going to put my dot on 2, and I'm going to go up 2 over 1, or down 1, 2 over 1. crosses at what point? What is x? X is 0. What is y? 2. So is this inconsistent, consistent, dependent, or consistent, independent? Consistent, independent, and I know that looks like it's crossing. You would have gotten the same answer if you'd done substitution or elimination. So if you use those, you will get the same answer. All right, let's move on. We're looking at this equation. X equals 2y plus 1, and x equals 2x plus 1y equals 7. Okay, well, it's not slope-intercept form. So I probably don't want to do graphing. But I could. I could solve it for y and do graphing. It's not in standard form. Is one of the letters all by itself? Yeah. So which one do I usually want to use when that's the case? Which one? When the letter is all by itself. Say it. Substitution. So I'm going to plug it in. I'm going to say 2 times 2y plus 1 plus 1y equals 7. So first thing I'm going to do is distribute. 4y and 1y are like terms, so I put them together. I'm going to subtract 2 from each side, and I get 5y equals 7, equals 5. And then divide by 5, and y equals 1. Now I'm going to plug it back in. X equals 2 times 1 plus 1. So x equals 2 plus 1, so x equals 3. So my final answer is 3, 1. Okay, I get an x and a y. So is this inconsistent, consistent independent, or consistent dependent? This is consistent independent. And if I was to draw the graph of it, or a sketch of it, would it look like 2 parallel lines, 2 overlapping lines, or 2 crossing lines, like an X? 2 crossing lines like an X. And I know this because it has one answer. Not infinite and not no solution. Okay, let's look at our final one. Okay, so this isn't in slope-intercept form, but I could get it there to graph it. It doesn't have one letter by itself, so yes, Thomas? Elimination. Because it's in what kind of form, Thomas? Standard form. So I'm looking at this. Well, I can't add straight down or subtract straight down. So what am I going to do? Yes, Thomas was raising his hand. Which, by what? What kind of 2? Negative 2. Multiply this bottom one by negative 2. Negative 2x minus 2y equals negative 10. Then I'm going to rewrite the other one right under it. Uh-oh. When I add these straight down, I get 0 equals 0. What does that mean? Okay, let's look at our different things. We know if we get an x equals something and y equals something, it's got one solution. We know if it's got something like 2 equals 0, we've got no solution. But we know if it's 2 equals 2, how many solutions do we have? Yes, Kyle? All real solutions. Or all real numbers. Either way works. What is this graph going to look like? Yes. Overlapping lines. It looks like this. Any questions? All right, ladies and gentlemen, we're going to pass out your worksheet now, but before you